It's honestly no exaggeration to say that this is the single most difficult technological challenge I've ever faced. Hey everybody, welcome back to the Magical Man Cave. Now this video is going to be slightly different to what I normally put out, because in this video I've created a Halloween decoration with a difference, I suppose. So I went to Sainsbury's, which is a local supermarket near to me. In this video, I'm going to be showing you how I customized a Halloween decoration to work with my smart home. And I'll show you exactly how I did that. It was a real headache with all the programming and stuff, but don't worry, I'm going to leave all the code down below in the video description in case you're interested in making this sort of thing yourself. So I picked up a Halloween decoration. It's a talking skull and it looks like this.
What are you looking at? Never seen a skeleton before?
So it's an American sound, which if you are American, that's fine, but we live in Britain and it just sounds a little bit out of place. So I've decided to replace the voice, and I've also thought, while I'm at it and while I'm replacing the voice, I may as well add the functionality. So this skull now looks like this. Before I show you the actual finished thing, because I think that kind of deserves a bit of a decent reveal, I'm going to show you the sort of interim thing as to the sorts of things that I'm aiming for in this video, and hopefully it'll give you an idea of what I was expecting and what I was hoping for. Ask the skull what he thinks of Halloween.
Okay.
Halloween? I've seen scarier things, like your fashion sense.
Okay, so not much difference. The eyes do look a little bit different, but the key point here is that it's going to react to all of the things that are happening in the man cave, whether that be the door opening or me taking a guitar off the wall. So I'm going to show you the process on how I actually went about doing this, and that involves taking it all apart and soldering twice because I dropped it once. There's an awful lot of networking stuff. There's also programming. If you are scared about technology, this may not be the video for you, because I'm going to go into a fair amount of detail on how I did this in case you wanted to do this yourself. But obviously, like, subscribe, ding the bell, all of that sort of wonderful stuff helps the channel. And if you want to know how I made this awesome thing, stay tuned. It's coming up right now. Okay, first things first, let's head on over to the skull. Let's take it apart and delve inside its brain. Right, so excuse the mess, and I know that we've got a glass in order to hold it up in the right position, but basically this is the skull inside. So you can unscrew all of this sort of stuff. It's fairly straightforward, and I did disconnect the LEDs of the eyes there. Now inside the skull, we've got a couple of cool things actually. We've got a speaker, which is located just underneath the jaw under here. Which I haven't rigged up. I've actually used external speakers, but you could, in theory, just wire those into the board and it will probably work, but I haven't done that. I've actually used external speakers. The other thing is, this part here is all linked at the bottom, just there where my thumb is. On the back, there's actually a battery compartment, which you can see just here. That holds 3 AA batteries. Now ultimately what I want to do is to replace the AA batteries with a power unit of 5-volt power supply direct from mains, which will allow me to power the mouth motor, but at the moment that's being fed direct from the battery supply. The other thing you've got here is the L289N motor driver board, which is all rigged up together into the motor, and the motor has a capacitor there to make sure that there's no sort of bouncing off the motor. And then the motor here is connected to this string, which controls this lever arm, which makes the jaw move. And then out of here, all the way up the back there, all these wires, they head towards this thing, which is actually the brains of it. This is the Raspberry Pi. On the motor driver board, the L298N motor driver board, in 1 goes into pin 18 and in 2 goes into pin 23 on the GPIO of the Raspberry Pi. Really, the Raspberry Pi is the brains behind it, and what it does there, it links in with the network cable just there so that we can make this thing smart.
That's for the speakers. And then all we do, once we put it all back together again, is program it. So I'll show you how to do that next. Okay, so any programming project needs to start off with some logic. That doesn't necessarily mean that you start out understanding exactly how to program things with the syntax, but just to think like a computer. So I'm going to head on over to my iPad and draw out kind of what we need to do, where we need to go and that sort of stuff. The first thing we're going to need to start out with is some sort of command module, some sort of way of getting the commands into the skull. For me, I'm going to use a Home Assistant server that I've already got, which controls all of my smart home stuff. I'm then going to use something called an MQTT broker on the Home Assistant server. And what that will allow me to do is to send messages from this server to the skull. So the skull is going to be called the client machine, just so that you can understand what I'm talking about. The server is the Home Assistant, the skull is the client. So what I'm going to do is to send messages from the server to the client, and the client's then going to read that and do certain things. The next thing I'm going to need to do is to work out 3 different types of script. One to turn the motor on, one to turn the motor off, and the other one to do all of the other clever stuff. The clever stuff means take the MQTT message from the server, read it, interpret it, and play an MP3 based on that. Now, because I want the skull to be able to do a whole load of different actions, what I figured was probably the best way of doing it is to have a file structure where I have lots of different folders for lots of different actions. And those folders can be named clever things like default for just standard messages, or sassy for when I want the skull to give me a sassy comment, or Christmas for Christmas messages, that sort of stuff. Also, I've got other things like guitar on, guitar off for when I turn on or turn off the guitar, lights on, lights off, door open, door close, ice machine on, ice machine off, those sorts of things as well. And because each folder is named like that, then I can start putting MP3s into those. And then when the MQTT message comes through, it's going to read the payload of the message, and I'll explain that in a second. Hi, Future Neil here. I totally forgot to tell you about the MQTT stuff, and I'm editing the video now, so I thought I'd drop in and say this is what I'm talking about. When it comes to an MQTT message, there are 2 things. There's the topic and there's the payload. The topic is basically like saying this is what we're talking about, and the payload is like the body of what you've actually said. So in our example, we've got a topic of skull/play, and the payload might be Christmas if you're talking about something Christmassy. That payload has got to coincide with whatever the name of the folder is. That's the easiest way I found of doing it. There is an easier way, ultimately, which I'm still working on the prototype for, but I will do an update video about that as I develop it. It's really exciting, but for now I'm using MQTT messages and it works brilliantly. And it'll take that payload, it'll convert it into a folder name, and then that folder name will then be where to look for a random MP3. The reason I'm doing a random MP3 is because I don't want the skull to say exactly the same thing every single time. What I want it to do is to play a function like, oh, I've just turned on the ice maker, and it has a whole bunch of different things that it might say for the ice maker. And I don't know from day to day what it's going to say when I turn on or turn off the ice maker, when I turn on or off the lights and that sort of stuff. It just helps keep it a bit more fresh. And it's also infinitely expandable as well. You just add extra MP3s into the relevant folder and it can say extra stuff, which is really neat. Okay, so now that we've got the Home Assistant server sort of working, we need to make sure that that's on a static IP address, because the skull needs to subscribe to a static IP. It needs to know basically where to look for the MQTT messages that the Home Assistant server is providing. Next up, we need to trigger all of these MQTT messages using the Home Assistant server, using a helper within Home Assistant. If you don't know how to do that, there are plenty of other tutorials on how to do that. This video is getting long already, so I'm going to assume that you know how to do that. Then we use the MQTT broker that we've installed on Home Assistant to broadcast the message with skull/play and the payload of whatever event is being triggered. And then the clever stuff is within the skull script itself. So let's tackle that. Once we've got the payload, we're going to find out what folder to look in for a random MP3. We then take that, we then chunk it into various different sections. There are 3 things to remember. There's the size of the chunk, there's the power of the MP3 itself, and there's the sort of rest time, if you like. Now, you're gonna need to probably tweak around with those things a little bit, but if you use the script that's down in the description, you shouldn't go too far wrong. That script then references the on and off functions that, again, I've linked down there. And then that's pretty much it. That's all you need to do. Isn't that wicked? Just while we're here, I've got these cocktail cards still available. I've also got my book, which is up on the shelf there. So if you want any of these sorts of things, have a look on my website. Again, links down in the description. It's a really super good deal, and you can get these in time for Christmas. Okay, so here he is now mounted inside the wall. And what's really cool is that as I open the man cave door, it will actually respond to smart home triggers by doing this.
Ah, back for more magical abuse, are we? Very brave. Or very stupid.
This talking skull itself is only £10. The other stuff that you add to it, you could take or leave the eyes, but with regard the mouth and making all of that move, it's not that much. The motor driver board is fairly cheap, and the Raspberry Pi itself, admittedly, that's probably going to be the most expensive thing. Beyond that, though, it's fairly straightforward, it's fairly easy, and you don't even need a modern Pi to do this. So let's sum up. If you haven't done already and you like this video, please like, subscribe and ding that bell, because it really, really does help me out, I promise you. Yeah, you can tell I haven't recorded anything for ages. Thanks so much for watching. Tell your friends, and until next time, as always,
Stay magical.